let's know what are the different types of machine learning. The machine learning broadly classified into supervised, unsupervised, and reinforcement learning. Supervised machine learning is the task-driven one, which predict the next value kind of thing. Unsupervised machine learning is a data-driven one, which identify the clusters in the data. And reinforcement learning is completely a new strategy where it learns from mistakes. Supervised learning model. This particular diagram depicts what supervised learning model and how it is working. There is a machine learning algorithm here. You look at it takes input as training set along with its corresponding label. The training set may be a text data, or it could be a documents, or could be image, or it could be any kind of past experience that is having corresponding label. For example, if your training set is having a collection of animals, images of animals, then every image will be having, if there is a dog image, corresponding label dog will be there. If it is a cat image, corresponding label cat will be there. Likewise, every data will be labeled and given to machine learning algorithm. So the training happens at the model, and once the training is done well, the model becomes efficient to predict any new data. The new data, you please note very keenly, for the new data, there is no label given. The label is predicted. The label is predicted by the algorithm which is trained with the past data. So here the feature vector meant for the data is not going to be given directly to the algorithm. It is converted into feature vector, right? The feature vector is with the input. In some machine learning algorithms, like advanced machine learning algorithms like convolution neural network and the kind, takes the data in a pure form. There is no need for feature engineering there. It itself extract the features. Okay. So the supervised learning algorithm takes a set of data along with its label and trained, and it can be predict the future occurrence of any data to the corresponding label. This is what supervised learning model. Look at the supervised machine learning approach and how to notate it and the theoretical background behind. The goal here is to learn a mapping from inputs that are called X to outputs that are called Y, given a labeled set of input-output pairs. In supervised machine learning, we used to give data as a pair. One is the input and its corresponding label. And here, see, this is the notation of machine supervised learning, where D equal to a set of xi comma yi, where I varies from 1 to n. Here D stands for the training set, which comprises of data, n number of data, and it's with its corresponding label. That means actually is written in this notational form. D is the training set, N is the number of training examples. Here, Xi denotes input. This input could be either n-dimensional vector of numbers, like, see, suppose if our data is saying the height and weight of a person, accordingly, we classify them into obesized or non-obesized like thing, or it may be a complex structured object, means the data could be an image, or it may, in case of image classification, or it could be a sentence in case of sentiment analysis. It could be even an email message where we use for done for spam classification, and it could be a time series data like molecular shape, or it may be a graph, etc. And output is the y, which is also termed as response variable. It could be either categorical or nominal variable if your task is classification. Like we can classify, categorize the people as male or female, or anything, any prediction as true or false. Like so, classification or pattern recognition may be of categorical or nominal variable as output. And in case of regression kind of task, the output could be a real valued scalar. For example, what may be the income level or what may be the stock price in the next coming days. Like that is what prediction. So regression task use real valued scalars. Suppose if you are doing any ordinal regression, your y could be any natural ordering like a to f or x to something z, like any grade 1 to 5. Like here, actually, in supervised learning, this is simply a task of mapping an input to its corresponding output. That output could take maybe an element of a set of classes 1 to c. In case of binary classification, the C will be of 2. And if in case of multi-class classification, C will be more than 2. C means a class. Here, in order to formalize the supervised learning task, we have a concept called function approximation. Function approximation is here play a role in mapping the input to its output. That's how we assume y is equal to a function of x. This is the way we map. The function actually maps x to the corresponding y. Here, the function f is unknown. That is being learnt from the past experience. But the goal of f in learning is to estimate the function f given a labeled training set and then to make predictions using y equal to f of x. So this particular function is giving you a probabilistic output. We can always compute the best guess or true best guess so that the function is maximized to the maximum of the probability. So y is always a function of x, which yields correct label class, which assign x to the appropriate class C, we can say. Maximize the probability of assigning to the class is maximized with argmax of assigning the data to the corresponding class with a probability of p, where y is taking assigned to C give for the given x with respect to the training example D. This is how actually the function approximation is used to map input to the output. It is also known as maximum posterior probability. Maximum posterior probability, a map. This is a map estimate. The problem is always a posterior problem. We need to maximize the probability, posterior probability. Since this is a map, posterior probability, has been written as a conditional probability equation where y is assigned to a class subject to the given x and the past knowledge d. Look at this example, supervised data. This is the training set of samples and a new sample. See the training set of samples. There are 6 various samples with the category. Actually, example data. You see training examples are labeled set and new examples are not labeled. The action has to be predicted here. This is the label. Here, the question mark stands for that the classification has to be predicted. That is why. Actually, as usual, the other features are given in the new samples too, but the action is not given. That is the label not given. Based on the learning what we did on this training examples, we have to predict the appropriate class for these features, right? Unsupervised learning, we look at this image, which is much similar to a supervised learning, but one thing is missing. I hope you'd have predicted what is that one thing. Here there is no label. Only the machine learning algorithm takes the training set which do not have label. Only a blank features we are giving. So as usual, from the training set, the features are extracted and the algorithm trains and the model predicts the new document, and it actually cluster the document, add this a new data to the respective cluster or respective group, we can say. So the prediction here is the likelihood of taking part in a particular group, right? So the unsupervised learning model, since there is no label, maybe the goal is to learn a mapping from input to output without any predefined class labels. So we have to find an interesting pattern in the data, how the data are similar to each other. Okay, like once you find out the similarity between the data, we can group the data very easily. Suppose assume that there are a group of students in front of you. There may be a mixed level of heights of students. Suppose you wanted to group these students according to their height, maybe the taller group and shorter group. So we have to start with, we have to, what you see, what you will manually, if you do, what you will do, we have to find a person randomly who seems to be taller and another person randomly, maybe a shorter, and c- compare the others with both of them. And to whom the new person is much similar, you attach them to that particular group, right? That is what grouping occurs. That is what interesting. This is what the interesting pattern in the grouping data. So that the unsupervised learning could be written as a set of training for a set of training set. There could be a data only, no label, where xi varies from 1 to n. So there is a D set of training with n number of training examples. Next is the reinforcement learning. As I said, reinforcement learning follows a different strategy where the output of the system is not a single action, it's a sequence of action. So the single action is not important here. What is important is the policy, that the sequence of correct actions to reach the goal. So we have to formulate a policy of sequence of actions which leads to the correct destination. So for example, you start at your home. There are multiple ways to reach a certain place which is new to you. So you started moving in one direction, and if you could able to reach your destination with the lesser, shortest length or without any hurdles or block of roads like that, that route can be recorded in your map. Because in future, you might have prefer the route, right? So similarly, you can take other route and find out whether it may takes you to the destination, right? The very simple example, very common example, what reinforcement learning can be compared is chess playing. So there is chess playing game, the two players started playing with the preferred color of coin. They started moving. The winning is not decided, or any winning moment, milestones is not decided by a single move. It's a sequence, no? That's what. See, the reinforcement learning have two components. One is the agent, another one is the environment. The agent is allowed to perform certain action A onto the environment. If the action is a successful action, then the agent state is changed to SI to ST plus ST to ST plus 1, and it is rewarded. Otherwise, the agent is penalized. Let's say the reinforcement learning example, as I mentioned, it is chess playing game where the environment there is the chess board. The agent is the one who play, right? So all game development algorithms or reinforcement based algorithm, right? And then a robot navigation in an environment is similar the reinforcement learning. We used to train the robot by reinforcement fashion only. The robot started, allowed it to move in a path for all the predefined number of moves. It can go straight, it can go right or left or back, whatever. That movement of the robo has to be positive. It should be a successful one. If any hurdles present, that way the robo move is the wrong way, so it has to come back. So that action is not rewarded, but it is penalized. So the robot navigation algorithms all are reinforcement learning basis. Thank you for listening. Let's meet on the next class.